It starts with, of course, the data collection, as you said. Most of these units have tens of thousands of sensors, which are capturing everything about the unit from the temperature, the pressure, the speed of the air in different parts of the unit, etc. So the first part is, of course, collection of the data. And then, as you can imagine, there's going to be some errors in the data itself because sensors go bad, they're not calibrated, and things go broken. There is some redundancies, etc. So you go through all of that cleaning, which is going to be a massive effort to finally get a set of clean data that is probably representative of what a unit looks like when it is running in a stable manner. Once you have that, then you can train what we call predictive models on top of it, because it's a two-stage process for this particular use case that you explained, right? It's similar to how, for example, Google Maps would work. If I am trying to train a model, first it needs to know that if I take a certain route, how long will it take me to get to my destination? And then once it knows accurately the relationship between a route and the time, I can tell it to now reduce my time, and then it works backwards. It tells me what route should I take to reduce that time. And same thing happens with this, nuclear reactor or any kind of power plant optimization model. First, it needs to know that if I run it in an X manner, what's my efficiency going to be? And once I'm confident it understands that relationship, I work backwards and I tell it I want higher efficiency, work backwards and give me the route to get to that higher efficiency. So that's generally like a high level process. I have a controversial opinion on this one, right?